Hey guys, so if you guys have any tips for me on how to record these things better or anything, just let me know on Blackboard or whatever, email me or something like that, because I am new to all these recording and online kind of stuff. So if you have anything useful for me, please help me out. Okay, so we're going to be looking at the Desmos versions of these vertical asymptotes. Do you guys remember the last lecture, or rather the last video? We were trying to graph this guy 2 divided by x minus 1. Well, in particular, we want to find that if there was a vertical asymptote for this function. And so what we did was we set the denominator equal to 0, and we found out that yes, we indeed have a vertical asymptote at x equals 1, because if we plug in 1 into this function, we would get 0 in the denominator. So let's go ahead, graph this guy, see what happens. All right, and there you go. So here's x equals 1 right here, right? And let's look at what happens to the curve. Look how our graph is trying really hard to avoid letting x equal 1. Or, yes, x equal 1. So it's kind of like gliding out of the way to get away from x equals 1. Even on the left-hand side of x equals 1, look at what happened. This guy, our graph is trying so hard to not let x equal 1 that these guys just keep stretching all the way out into infinity. They just keep going upwards into positive infinity. They keep going downward all the way to negative infinity. They want to do everything in their power to avoid x being 1. So now let's look at our second function. Remember, our second function was, what was it actually? X squared minus 9 divided by x squared minus x minus 12. So we said that there were a vertical asymptote at x equals 4 because we make the denominator 0. So let's go ahead and graph that. And look at this. Again, the same thing is happening. Here's x equals 4. And what's happening on the right-hand side and the left-hand side? Our graph is trying really hard to avoid being x equaling 4. See, they keep going, stretching out to positive infinity on the right side and then negative infinity on the left-hand side. I don't know what's going on with my computer right now. So notice too that we also said one other thing about our graph. We also said that yes, it does have a vertical asymptote at x equals 4, but it most definitely has a hole right there at minus 3. See? And right there we can see at minus 3 our function is undefined. All right, so keep toggling back and forth between these pictures and the previous video, and then you'll start to see the correlation. And what I mean by vertical asymptote is that there's a pretend invisible line right here that our graph does not cross. All right, see you on the next one.